Have you ever come home late and you're fumbling for your keys in the dark? You grab something cold and jagged and you just kind of know it's your key?
Yeah, and then you realize a second later it's, I don't know, a loose screw or a dog toy.
Exactly. You touch the shape and you make an assumption. And that is the exact vibe of the research stack we're diving into today.
It really is. We've got this provocative new 2026 paper that challenges the whole black hole status quo.
Right, but it's countered by some really hard data from the Event Horizon Telescope. So our mission for this deep dive is to figure out if our galaxy's heart is a hole.
Or a ball, a Fermion ball to be precise. This new proposal asks a pretty massive question. What if Sagittarius A star, that invisible monster at the center of the Milky Way, what if it isn't a singularity?
Like, what if it's actually just a super dense core of dark matter particles?
Exactly. And I know it sounds a bit like sci-fi at first, but it's actually really sticky.
It is, because it tries to solve two big headaches at once. First, it explains the stars whipping around the center,
And it also explains the rotation of the entire galaxy all the way out to the edge.
a unified framework, which actually is a perfect time to talk about unifying workflows. Because if you are trying to unify your business logic, you really need to look at Ember Silk.
Oh, absolutely.
Yeah, whether it's AI training or automation or software development, Ember Silk is all about finding where agents make the most impact for your business or your personal life.
So you could stop guessing in the dark.
Exactly. Check out embersilk.com for all your AI needs. So back to our giant space ball. The math works beautifully for the outer galaxy. So why aren't we rewriting the textbooks right now?
Well, because acting like a black hole, gravity-wise, isn't the same as looking like one. We still have to deal with the Eye of Sauron.
Oh, right, the glowing orange donut.
Yeah, we have to deal with those Event Horizon Telescope images. They show a shadow, which is a ring of a very specific size.
And that size matches Einstein's.
General relativity predictions for a black hole perfectly. To get a ball of dark matter, to mimic that exact ring size, you would need a density so precise it just feels mathematically rigged.
It's a huge fine-tuning problem. And then there's the thud problem, right?
The thud problem is huge.
Yeah.
If it's a solid ball of particles, any gas falling in would smash into the surface.
It would release energy and glow.
Yeah.
But the center is notoriously dim.
Right, which implies an event horizon, a point of no return where things just vanish into the void. No surface, so no thud.
Plus, I was looking at a 2024 study on the inner stars like S2.
Yeah.
They showed a dense dark matter core would act like a trap and disrupt their orbits. Yet S2 looks totally fine.
So we have a bit of a stalemate.
Mm.
Dark matter explains the outer galaxy, but a black hole explains the inner shadow and the void.
But here is the twist, and I think this is the most optimistic part of the research. It doesn't have to be one or the other. This is where the spike comes in.
Yes, the synthesis. The leading theory right now is that it's a supermassive black hole embedded in a super dense halo of dark matter, a spike.
So the black hole gives us the shadow and the void.
And the dark matter spike is still there helping hold the whole galaxy together. It resolves the contradiction completely.
I love that. And the best part is future missions, like the COSI Gamma Ray Telescope, are going to hunt for signatures of that exact spike.
It's beautiful because we aren't just guessing anymore. We are using these high-precision tools to test the fundamental nature of reality. That mystery drives incredible progress.
It really changes how we read the night sky. You know, we used to look at dark spots and see nothing. Now they might be the most crowded, complex places out there.
That is the most exciting part of astrophysics today.
Totally. So here is a final provocative thought for you to mull over. If dark matter clusters around black holes, does that mean every black hole is actually a dark matter lighthouse, just waiting for us to turn on the right telescope?
That is such a fascinating possibility to think about.
If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.